Okay, now that we have covered the, what do you call this? The magnitude part of the solution, we are now going to compute for the direction. Alright? So, I hope you have seen the review that I have created for you to refresh your memory regarding trigonometric function. Anyway, where would you be placing the angle? So the angle would be, always remember that the turn of the angle when performing the Pythagorean method of solving for the resultant vector, always utilize the x-axis or the x, I mean the one that's running horizontally or running on the x-axis. So this would be that, right? This angle. Okay, so this is, so you can notice this is an arrow turning to this direction. Alright, so you're going to place it here. Okay, that's our angle. So after knowing that, we can now find the answer. Okay, so the solution for this would be, so we are provided with leg A and vector A and vector B, so that would be equivalent to the triangle leg A and triangle leg B, which are the opposite side and adjacent side respectively. So what we're going to utilize is TOA of the SOHCAHTOA, so that would be tangent, right? So angle is equal to tangent inverse. Okay, so just write it here that tangent inverse, what's this, opposite over adjacent, right? Okay, so here this would be, what's the opposite side? So we have 12 meters divided by 5 meters. Okay, so cancel the meter because you know that the unit of this is degrees, right? So just try to calculate that. Can you see it? There, so tangent inverse, okay, divided by 12 over 5. Okay, can you see it? Okay, so that's the correct solution. So what's the answer? Wait, is this in degrees? Wait. Right, so let's try that again. Tangent inverse. There. So our answer is 67.13. Okay. Always grab 2 decimal points on the angle. Right. I mean 2 decimal places after the decimal point. So the answer would be angle is equal to 67.38 degrees. Alright, so key points that you have to remember. First, write it in Gresa. Always illustrate your problem. Write the given with proper labels of the variables and the units, identify the required. So in this case, it would sometimes be the resultant vector, sometimes it would be one of the vectors, assuming that it's the Pythagorean method. Then for the equation, you have two. You will always have two, one for the magnitude and one for the direction. So you can combine those in writing a single equation. We're going to do that later. For the solution, cancel the necessary units, so like what I did here. And then for your final answer, box it. Okay? So I would have an easier time of looking for the final answer. If possible, box it using a different colored pen. Okay? So that's it. Proceed to guided practice problem 1, and I'm going to show you the solution of how to do it.